Hello and welcome back to my channel. I'm Upasana Taneja. So in this video we have a question where we are given 5 raised to power square root of a plus 5 raised to power square root of a is equal to 80 raised to power square root of a. That means equation is in one variable only, that is a, and we need to find out the value of a only. So it should not be hard. Let us proceed. Okay, what would I do? Since I know that 5 raised to power root a, they both are same, right? If I add them, they would become 2 times 5 raised to power a, okay, is equal to 80 raised to power a, right? Okay, so here we have 2 times 5 raised to power a, and 80 can be written as 16 times 5 raised to power a, which can again be written as 16 raised to power a times 5 raised to power a, right? Because ab raised to power x is equal to a raised to power x times b raised to power x, right? Okay, so here we have 2 times 5 raised to power a. If I divide both sides by 5 raised to power a, right, I would get 2 is equal to 16 raised to power a, right? So if I can see that left hand side is 2 raised to power 1, but right hand side is 16, and I know that 16 is what? 16 is 2 raised to power 4. So 16 raised to power root a will become 2 raised to power 4 raised to power root a, which would be equal to, since I know that power raised to power, they get multiplied with each other, right? So it would become 2 raised to power 4 root a, right? So instead of 16 raised to power root a, I will write 2 raised to power 4 under root a. Now as we can see that denominator is same, so we can equate the powers. This means 1 is equal to 4 under root a, and this would give us under root a is 1 by 4. And if you square both sides, a will be equal to 1 by 16, right? And which is our answer, right? So this question was not hard at all. We just need to solve it step by step to get the correct answer, right? If you like it, do subscribe to my channel and please visit my channel for Maths Olympiad questions, for beginner to pro packages, okay? And if you like to solve maths riddles, you can follow me on Instagram and Facebook. Thank you.